Hi, my name's Peter Elger. I'm the founder of a company called Fortherum. We do a lot of work in microservices, DevOps, and increasingly machine learning and machine intelligence. And I'm talking tonight about how we minimize the difference between our development environments and our production environments so that we can more effectively develop microservices and more effectively shuffle them down our deployment pipeline into production without getting tearful, and hopefully have happier lives all round.
How you organise your microservice development environment, and then how you make that flow seamlessly through into production. I'm the founder of Fortherum. We're a new company, we're a startup. Previous to Fortherum, I worked with Richard. I was CTO of Nearform and one of the co-founders. Fortherum, really, the mission of Fortherum is really to deliver DevOps, microservices architecture, and so on, but also to move into the machine learning, machine intelligence space. We have a big interest in that, and we're starting to grow some projects and grow some experience in that sector. I guess just to say, over the last 2 or 3 years, I've spent a lot of my time working on microservice systems, consulting for kind of large blue chips who are looking to move to microservices. Been exposed to a lot of craziness and a lot of kind of misinformation out there, but had a lot of fun doing that. And really, for a certain type of system, microservices really are the way to go. But I had a particular itch I wanted to scratch, and I'll come to that in a moment. The topic of this talk is really minimizing the delta. So how do you minimize the difference between your development environment and what goes out to production, right? Because ideally, we would like exactly the code that we have in development to go out to production without any little tweaks or environmental differences. We want to make that as close to production as we can, so that we don't get caught by any horrible works on my machine type bugs, or it was okay in development. Okay, so part of that is how we can improve our development tooling and experience, reduce the friction, and then obviously be happier and not waste our time or our lives on all this stuff and drink beer and eat pizza and all of that kind of stuff. But first, just a little side thing. I know Dave's done this already, so I'm going to have to do it as well. My apologies. Shameless plug for a book, authored with some of my chums in Nearform, the Node Cookbook. I could highly recommend chapters 10 and 11, the best ones in the book, I have to say. Coincidentally, they're on microservices and deploying microservices. The rest of it's pretty good as well, in fairness. First of all, why microservices rule? Well, first of all, they're not a new concept. And I suppose people coming to the topic to begin with look at microservices as a kind of new trend, as a new buzzword. It's not a new trend at all. And anyone that's been in the industry or is as old as I am, I won't confess my exact age, will understand that they're not new, right? So if anyone who's familiar with the Unix tool set and piping commands together can see parallels between microservices and the Unix command line, because you have one tool, it does one thing well, and that's it, right? So, for example, ls understands how to list files, or grep understands how to search for strings, right? It doesn't do anything else. Whereas if you compare that to, I don't know, Visual Studio or Eclipse or something like that, huge, great big monolithic IDE does a whole lot of stuff, right? So that kind of notion of sharp tools that just do one thing well is very much paralleled in the microservice universe. So that's an analogy I like to keep in my head. So small, focused, decoupled components that are very easy to reason about. And this is an important thing as well, because I'm sure you've all grappled with large monolithic code bases, and you know that it gets increasingly difficult to hold many things in your head. So when you're chasing down a nasty bug, you've got to hold a mental stack of, okay, I came from here, right. Now, most human brains, I'm told, can only hold about 7 things in short-term memory, right? So once the code is really complex, debugging that and actually building that mental stack is hard. So keeping the code size small means that we can reason about these services in a much simpler way, and we usually write less bugs, and they're much easier to test as well, right? Most of the time, you can write microservices that you can have a 100% unit test coverage, and you're pretty sure that you've got most of the bugs out of them. You certainly can't say that about large monolithic code bases, right? Of course, it supports this kind of rapid iterative deployment models, which we want. Individual scalability, David touched on that in his talk as well. And this is a really important point, right? Strict vertical separation of concerns, super important, right? Because what happens with monolithic code bases is that you get a bleed over. It suddenly becomes quite easy to, well, should I do the right thing and talk through this kind of object, or will I just kind of hack the value in here? And over time, that entropy builds up. And if you've ever done any consulting, you'll go in and see code bases, and you're just kind of, this is why I have no hair actually, because I go in and I see all these code bases and I end up pulling my hair out, right? And I've seen so many of them that it's just, anyway, you pull your hair out and you think, how the hell did you get to this place? Well, you got there slowly over time, hack after hack after hack, right? So that strict vertical separation of concerns is super important, which means they're resilient to software entropy. Okay? So that's what we like about microservices. What sucks about microservices? Well, there's a few things that suck about microservices. Firstly, shell-hal. Anyone heard the term shell-hal? Anyone experienced shell-hal? Okay, right? So shell-hal is when you start with a little system like David's system, you've got 2 services, suddenly you add another one, and then another one. And in development, you have to pull up, run this window here, this window here, this window here, and suddenly you're jumping between windows to do stuff, and what's the state of this one, right? Horrible. That's pretty sucky. The reason we have shell-hal, by the way, is because most development tools are oriented towards monolithic development. So monolithic IDEs tend to produce or are oriented around monolithic software code bases, right? And they're great at doing that, but we'd rather not do that at all. We'd rather not need all of that tooling. We'd rather just be able to understand our code in a text editor, because then it's simple, right? And our chances of making mistakes are lower. The other thing that's sucky about microservices is service discovery. And David spoke about service discovery as well. There's many ways of doing service discovery. And then, of course, environmental differences. People having code that runs in production and code that runs in development, because I've just got to tweak this value here. So those are sucky things that we want to get rid of. So how could we make microservices suck less? Particularly, how do we make it suck less in development? Well, if we could manage processes en masse and stop-start everything together, that would be pretty cool, right? Because then we wouldn't have any shell-hal. We could do that with a custom script. I've certainly done it with a custom script where you just write a bit of bash and it pulls everything up and then pulls everything down, and it's okay, and it works, right? And you tend to do it on a kind of project-by-project basis. Docker Compose, I'm not a fan of Docker Compose, I have to say. So obviously Docker, the actual container engine and so on, we all use it when we're building and deploying containers. But Compose, it's difficult to see where Compose really should fit within the stack, right? It's not really a very effective development tool. You can use it for development, but the issue is that you've got to, how do you percolate your changes? Do you build a container every time, which is like a really, really slow development cycle? Do you export a volume, so you've got all that set up to do? How do you then restart on changes? All of that kind of stuff, right? Makes Compose a little bit meh for me, to be honest. The other thing is, can we use the same service discovery mechanism in development as we use in production? Well, let's say we're using DNS. What do? You hack your host file? Great, that'll work for a bit. But what about when you've got to run 2 or 3 different kind of services? If you're a consultant like me, you've got to manage and look at different code bases. You keep hacking your host file, it gets a bit messy, right? Console, yeah, console's great. You could run a container, a sidecar, but there's some setup and stuff involved with console, all right? So, if only there was some tooling that allowed me to work with processes, not containers, for a fast workflow, but gave me a mechanism to do service discovery in the same way that I configure my containers in production. Because that way, I could have a fast local workflow without having to mess about with different environment configurations, and my code could flow easily through my development pipeline. I deploy with Kubernetes, and some nice color output would be really nice as well. Okay, so Fuge. Fuge is a microservices shell that myself and a few guys have developed and kind of added features to over time. And it was really, I guess, where a lot of things come from. Once you start working with these systems, you want a way to improve your local development environment. So really it was just scratching our own itch. We wanted to improve our working environment because we were actively involved in building microservice systems for clients. So how can we do that more effectively? Well, first of all, let's be able to manage multiple processes, okay? Let's then emulate our production environment. That means all of the environment variables that you would normally use, let's have those injected by the tool. Let's emulate our production service discovery. So let's emulate DNS, for example. Let's emulate how Kubernetes works for its, when you're running your containers in production. There's a certain way that Kubernetes will run DNS. Let's emulate that. And let's make sure we can work seamlessly with infrastructural containers. So by infrastructural containers, what I mean is to differentiate running something like MongoDB or MySQL in a container, I would kind of refer to that as an infrastructural container, compared with a code container, which is where your actual code is built and executed and run, okay? And let's work with rapid process-based development, because running processes allows us to change our software quickly. We don't want to be messing around containers when we're developing, but we want to be able to shoot straight to containers out to production and know that the code we've built is going to work exactly the same. So minimizing the delta between what we have on our laptops and what actually goes through the pipe into production. So if you want to play along, by all means go ahead. I haven't seen too many laptops. There's been beer and pizza, so you can take this this later. Fuge is built using Node.js. However, none of this is specific to Node.js. So the development could be with could be Java, could be Scala, could be any language. Okay, it just happens that the tool is built in Node.js. MIT license, so free. Do what you want, fork it, whatever. I don't care. There's the repo. There's some examples there. So some of the examples I'm working through now are up on the examples repo. So knock yourself out there. And I'll talk a little bit about Concordant, which is a small module that helps with that DNS service discovery piece in a moment. So what I'm going to do is I'm going to run an example system. And I have to say, David, when I looked at your example system with 2 services, I thought, maybe I overdid it a bit. Maybe I could have done a simpler system. But there's a little bit of meat on this system. So at the top end, obviously a web browser calling into an API, web application layer, a DNS service discovery mechanism, and then an outer service. All that does, it's nearly as simple as your date service. It just adds 2 numbers together, right? So we're worried about what the services actually do. An audit service. So once I do an addition, we talk to the audit service, and that records the fact that we've made these additions. And then an eventing service. So any event, so page accesses or anything like that, get put onto an event bus. The event bus is Redis in this case, so it's probably a little bit of a stretch calling it an event bus. It's a Redis queue, but you get the point. And that records data into, both of those record data into a MongoDB database. And then there's a little reporting tool. In this instance, I'm actually going to be running the databases in containers, just because it's ethereal data and we don't really care about it. But obviously in production, I would probably defer to the same model as you, as to not anything that's stateful to keep out of containers. Okay. Right. So let's run it. Okay. Bear with me a second. So first of all, what I'm going to do is show you the configuration. So Fuge uses a very simple YAML configuration file. It looks suspiciously like Docker Compose, but it's not Docker Compose. However, it does interoperate with Docker Compose. So there's a global section up here. I've put some additional configuration into this global section. So first of all, I said run containers. So this means that Fuge, when it comes across a container in its configuration, will start it using the Docker API locally. I've told Fuge that I want it to run an internal DNS server, and I want it to host that on localhost using this port number, and I want it to use this suffix service.cluster.local. You'll probably recognise that, right? Okay, and I'm going to give it the DNS namespace micro, and that will eventually end up being my Kubernetes namespace. I'm telling it that I want to tail the containers, so I want to tail the output from, not the containers, so the processes. I want it to tail all of the output and dump it to the screen and also to log files. and I want to monitor the containers, the processes as well. So that means that in the background it'll watch for changes, and if the change occurs, it'll restart the process. So as you're doing some integration testing with your system, you get that rapid restart. Okay, and then obviously don't exclude these from monitoring. Then I've got my adder service. That's the path to the adder service. That's the command to start it, and that's the port to run it on. And that's just replicated for each of the other services until we get to Mongo and Redis. And you'll note that these, instead of being type process, are of type container. So that just tells Fuge these are containers, start them with a Docker API rather than trying to run them using the operating system. Okay. Just as an aside, sometimes what I like to do when I'm running Fuge is to actually keep the infrastructure containers running in the background rather than stopping and starting them, which sometimes happens. So in that case, what you can do is to create a Docker Compose file, and in there I've got my Mongo container and my Redis container. This is a version 2 Docker Compose file, and then you can just include that in the configuration down here, and it'll work exactly the same. But if you happen to kill the Fuge shell, it won't kill your infrastructure containers. They'll be living in the background. It'll become clear in a moment, trust me. Okay, so now I'm going to load that that YAML file, that configuration, into the Fuge shell. Okay, that's started. And now if I just run a PS command, you'll see that I have my adder service, audit service, event service, my web app. So these are the microservices that I'm developing. Okay, and then I have my 2 containers. So this is just infrastructure that those services are using. So Fuge knows that these are of type container, and it knows these are type process. This one is actually specifically Node. That's to enable Node.js debugging, just because I happen to write quite a lot of my stuff in Node. They're stopped at the moment. They're being watched for changes, and we're going to tail all of the output from them. So what I'll do now is just start the system up. So start all. Okay, nice color output. Copy compose. So what's happened there is that you'll see that Mongo started up first. So one of the rules in Fuge is to start infrastructure containers first. Obviously, because your services typically connect to your infrastructure containers. So always start containers first, no matter the order of this listing, and then start processes afterwards. So I've now started Mongo and Redis. You can see the output coming from those 2 there. And this is just the standard Mongo Redis container that you would get by doing Docker pull Mongo, Docker pull Redis on your machine, right? Sorry? So they're empty at the moment, there's no data in them. So the services are going to write to them. If you wanted to bootstrap your data, yeah, you'd need to put some additional piece around that. Typically what I might do is to take a Mongo container, do my initial data, do my initial, do some additional data load, and then just save the container state out as an image, and then boot from that image rather than booting from Mongo, the base Mongo image. And then we can see that the adder service is starting up, audit service, and web app. So if I now run a PS again, you can see everything's up and running. And we can double check that because if we do... So for commands that Fuge doesn't recognize, it just passes them through to the shell. So we can now see that actually, yes, indeed, those node processes are running and everything's listening and waiting for connections. So if I just flip over here and I go to a bit of a giveaway, sorry, and go to localhost 3000, that's my ad service going through the web API layer. So we'll put in a couple of numbers. And we got the answer 2, great. And let's look at our audit service. And great, it's recorded the fact that we've added 1 and 1 and we got the result 2. Okay, whoopee, nothing special there, right? Except that, let's just have a quick look at the environment for each process. So that's the bunch of commands that are supported by Fuge. If I do info, add a, you'll see that this is the environment that Fuge injects into these processes. Okay, Dave, I'm going to ask you, you notice anything familiar about those environment variables? Exactly, yeah. Yeah. So that's exactly what's going. So we're emulating the environment that Kubernetes injects into containers, into our processes. The reason for doing that is because we can develop with processes really rapidly without messing around with containers, but they're going to behave in the same, the code is going to behave in the same way when it's injected into a container. Okay, so the other thing that Fuge is doing then, you might have noticed when I ran the PS command initially, is there's this DNS thing running here. So that's from us enabling DNS and passing in a DNS host into Fuge. So I can now inspect the zone. Okay, and Dave, you might recognize those as well? Yep. So again, these are the default format that Kubernetes uses for its internal DNS. Okay, so if you remember from the Fuge configuration, which is over here, if I just, go back up, you'll see that we said to use the DNS suffix as service.cluster.local, which is the default suffix for Kubernetes, and we wanted a namespace of micro. So you'll see that here, that Fuge is hosting two types of records. It's hosting an SRV record and an A record. So in the SRV record, which is main TCP, service name, namespace, and then suffix, there are two things. There's a CNAME record, which is add a service microservice.cluster.local, and then a port record, which gives us the port number for the service. And then you'll notice a corresponding A record for resolution of that CNAME record to an actual IP address. Okay, let me flip back to the slides for a second. So we run it. Let me explain what's going on there. So as I said, these are Kubernetes type environment variables. So within our code, when we start a service, when we start listening, we don't just put in a random port number or whatever we choose. We use what's injected by Fuge, or which will be injected by Kubernetes, which is, if I'm the adder service, then I need to listen on adder service port, right? All unassigned. So listen like that. And then on the DNS zone, as I've explained, you've got the CNAME and port records. So how does the service lookup work? Well, if I'm a consumer, I want to consume a service, I refer to it by name, right? I just need to know the name. Now, all right, it's a little bit clunky, and normally you'd probably wrap that in a small piece of code that just allows you to say service name, right? But the point remains, it's just a name. So we have a piece of code in every consumer that says, okay, give me the server record, SRV record for this name. That returns a port number and a CNAME, and then I ask it for the corresponding A record, and that gives me an IP address. And so the combination of IP address and port number allows me to then connect and consume to that service, typically using HTTP. Now, the other thing that we do is, of course, in development, we don't really want to be messing with the host, the underlying host's DNS configuration, right? So we give the Fuge internal DNS server a port number to run on, usually 53053, could be anything. Internally, that resolution process uses a small module that looks for the presence of a DNS host environment variable. And again, that's injected by Fuge when DNS is enabled. If DNS host is set, then we do direct resolution. So we say, okay, we're going to use DNS host, we'll make a query directly against that DNS server. That's the DNS server that's being run by Fuge, and we get a result back. If DNS host is not set, we just use the system resolution. So resolve.conf, whatever the standard configuration is, right? And when the code is running within a container, Kubernetes sets up the appropriate resolve.conf configuration. You're pointing to the Kubernetes. You're then going out to the Kubernetes DNS server and your resolution happens in exactly the same way, just going through the system DNS rather than a direct lookup. Okay, so you just say, internally when you want to consume a service, you say DNS.resolve, and you get back a port, and you get back a host, and then you connect and you consume. So there's no port numbers, you just have a name, and everything resolves from there. Okay, so let's test it. Let's run it in Minikube. Dave, you didn't touch on Minikube, did you? I don't think. So Minikube's a great way of experimenting with Kubernetes. You can basically just, I think on a Mac you can brew install Minikube. I think I brew installed it. It was a while ago. It's been running for a time on my system. Brew install Minikube, and that'll allow you to run a single node Kubernetes cluster on your local machine. So it's great for kind of playing with Kubernetes, getting an understanding for how it works, and carrying it around. You can run it without a network cable, and so on. And for us, that's going to be a simple staging environment. So what we can then do is build our services as a set of containers, push those to Docker Hub, or you can run a local registry, push them into a registry. Kubernetes needs a registry to pull from. Then deploy it into Minikube, and this time we'll have the same service discovery mechanism, but this time Minikube is taking care of it rather than Fuge. So that looks a little bit like this. Apologies for the Jenkins reference. I'm not using Jenkins in this case. This was taken from a different talk. But essentially our code, we commit to GitHub. One would normally then put some kind of automatic trigger on that. You get Jenkins to build your containers, push them into Docker, up to Docker Hub, and then deploy them into Kubernetes on trigger. So let's just run that. Sorry, I'm just. So if I just come over here, you'll see, actually, and one of the good things is that you don't need to set up a proxy or anything else. Minikube comes with the appropriate stuff to allow you to look at the dashboard. I think the command is just Minikube dashboard, and it'll fire up your browser and you can see what containers are running. So as you can see here, we've got all of our containers. So add a service, audit event service, Mongo Redis, and so on. If I come back over here, you'll notice that the IP address I'm using is not localhost. That's because Minikube is running within a VM. So you need to get the IP address for the VM. So in this case, I'll show you how to do that. The command is just, sorry, I better quit out of that. So I was just exiting the Fuge shells there. It's killing all the containers and processes it had running. So if I do Minikube, that'll tell me the IP address that Minikube is running on. And I just need to do one small thing. So I can now use sorry, mistype. Sorry, my typo. So you can use, with Minikube, you can use the same kube control commands that David was showing before, but they're all now pointing to your local host. So what I was doing here with this kube control config was pointing kube to the Minikube instance. So if you want to address a different Kubernetes cluster, you just change the configuration and you can point it to one in Amazon or one in Google Compute Cloud, exactly as in the manner that David did earlier. So you can see that I've got a number of services running in there. So let's go flip over here and just show that working as before. So here's my adder service. This time we're adding up fish for some bizarre reason. And we submit that, and then we can look at our audit service. I've got a calculation history there. So it's working in the same way, same service discovery mechanism, but this time it's all within Kubernetes running on our local machine. And we can actually make a change and deploy that into Kubernetes if we want. So let's do that now. Let's go to our adder service, and No, actually, let's go to web. So let me change that. In fact, look, I've changed it already. So rather than adding fish, we're just going to add it up. So we'll switch back here, and so I'm just going to rebuild the containers. So I've just got a little build script that is just looping through and building each of those containers. And once it's built each container, it's pushing it up to Docker Hub. So that'll just take a moment to run, depending on our network speeds here. Yeah. So whilst that's building, what I'm going to do next, once this is built, is just to deploy this update into Kubernetes. That'll pull the fresh containers down, and we should see the change appear in our web page. Okay, that's done. So I'm just going to do. So that's now going to deploy those changes into Kubernetes, and if we look over here, we should see these updating. So as you can see, it's just pulling fresh containers down from the hub. And we'll just wait for that to complete. Great. Okay, that's done. So if we now go back to our adder service here, we should see our changes reflected in there. Now, that's okay, but imagine that can't be a development work cycle, right? That just couldn't be. That's the point of having Fuge. If you've got to do that rebuild every cycle, it's going to take you days to do anything. Anyone remember J2EE? Huh? Anyone remember trying to get shit done in J2EE? And I still wake up in a cold sweat, right? But you were just trying to change a web page, right? Or you're just trying to make a change in a piece of text, and you had to go through this horrible level of incantations to actually see your change, and so your development cycle was slow. So the point of having tooling like Fuge is to have a very, very rapid development cycle. You need your changes to come up very, very quickly in development, but you want all the benefits of containers, but you don't want that to slow you down in development. Okay, so that's the reason why we built that tool. Okay, sermon over. So I have to say that I do agree with David. You should use a managed Kubernetes service wherever possible. It takes away an awful lot of pain. I'm a bit thick, so I deployed it onto AWS. However, in my defense, I cheated. If you do want to play with Kubernetes on AWS, there's a great little tool called KOPS, K-O-P-S, stands for Kubernetes Operations. That will allow you to actually generate a 3-node cluster in very little time with a bunch of kind of sensible defaults, and then deploy that up into AWS with a couple of commands. It takes 5 or 6 minutes for that to actually build in your infrastructure. Once that cluster is built, you can go and create a namespace and then deploy your containers into it using kube control in the same way as we've done just here, right? So it's a good way of experimenting. I guess the caveat is that you wouldn't take that cluster that you've built with KOPS and then try and run it in real production, because there's a lot more that goes into management of a Kubernetes cluster than that. And that's the reason for using the managed or hosted system. But in this case, I've got a little cluster I built in KOPS. You need to set up your AWS command line tools. If you're familiar with AWS, it's quite straightforward to do. It involves a bit of Python and bits and pieces, but it's straightforward enough. And then you point kube control to that cluster, and then you can start pushing your containers into AWS. So it's running on top of your kind of EC2 infrastructure. And again, the point is that we're using the same service discovery mechanism. We haven't changed our code. We've now gone to a production environment without change. So if we come over here, this is the cluster that I'm running. I've got 3 nodes. This is the nodes that KOPS, sorry, damn you PowerPoint. A second. So here are the 3 instances that KOPS built for me. And my cluster is now spread across those instances. I was lazy, I'm afraid. COPS doesn't give you the proxy and the management dashboard, so I didn't go ahead and install that, but you can install it. There you go, there's a reason not to do it that way already, okay? So if we come over here, what I need to do now is just point Cube Control to that environment. So I've called that environment for Theorem Demo. So I usually use a get nodes command or a get pods, usually a get nodes, just to check the context that I'm working in, just in case you're pointing at the wrong cluster, because that could be a disaster. Okay, so we have those. So sorry, yes. So if we just use kubectl get services, so that's our service list, and I actually want to go to the web app. So I need to use kubectl describe web app. Sorry, let's describe web app. Oh, I'm missing. Sorry, yeah. Missing an E. Sorry. It's not. It's difficult to do this after 2 beers, you know. Seriously. Okay, so part of what COPS did when we did the deployment was to create an elastic load balancer for us. So that rather nice looking host name there is the elastic load balancer that was created. So if we want to go and see what's actually running there, we come up here, and that's saying Alex the Fish. But there's our load balancer name there. There's our ad service. We can reload that. We can add a couple of numbers and submit that. Great, there we go. And then we can run our audit service. And all is good. So finally, okay, I kind of explained that, but that's the structure. Very similar to before, but we have an ELB in front, and we're running on AWS. So I guess other contexts where we've used Fuge that's useful. It'll emulate, if you want to use ECS on AWS and Route 53 for discovery, very, very similar mechanism. And so that DNS emulation that you use in Fuge, it maps exactly the same way. You just need to change the domain names and whatever domain names that you want to use on AWS, and just use those in Fuge, and then it works trivially. Console DNS, yeah, you can emulate that as well, because console has a DNS interface, so that'll work. I haven't yet used Fuge with gossip-based clusters, so swim, weave, surf, and so on. These are interesting. I do think the gossip-based discovery is interesting. However, I would say that probably the most scalable service discovery mechanism on the planet is DNS, and if it's good enough for the interwebs, it's probably good enough for me. I like to keep things simple. So in summary, I guess the points I'm trying to get across here are that we want fast local development cycles. So we need to be using processes. We need to start and stop them rapidly. We want to see our changes immediately. We have to have that. We want to be able to manage services in bulk. Okay, so we don't want shell hell. We want that bulk management. We don't want any environment-specific code. We don't want bits that execute in production or execute in development, because that just sucks, and that's a source of bugs, and particularly hard to find bugs. So to do that, let's emulate staging and production locally. Let's make them the same. Keep the delta 0 or as minimum as you possibly can with tooling. It allows us to drink more beer. Did I mention the book? Did I? Okay, it's a great book. Buy it. Chapters 10 and 11. Awesome. Me and David can have a fight in the car park afterwards, aren't we? Yeah. Okay. We're hiring. I'm always looking for smart people that want to come and join us in our mission. If you're interested in this kind of stuff, I'd love to have a chat with you. Also very interested, if anybody is interested in collaborating with Fuge, you want to use it in your own environments, and there's something that's wrong with it, please log an issue. Even better, send me a PR or get in touch. That's the repository just there. Or hit me up on Twitter, LinkedIn, any questions.